You're going to do 9 exponent button, whatever your exponent button is. I do not know. You have to know that. And you could just go 0.5, but I don't want you to do that. There's a reason. I want you to go 9 exponent button bracket 1 divided by 2 bracket. And tell me what the answer is. 3. Now do it here. 27 exponent button bracket 1 divided by 3. And what do you get? 3. Now do 625 bracket 1 divided by 4. 5. Now, this right here, I'm going to draw in red, is 9 to the 1/2 equals 3. Do any of you see a relationship between 9, an exponent of 1 over 2, and 3? Anything, just brainstorm. I'm not looking for the right answer. I'm looking for any relationship you can find between 9, 3, and an exponent of 1 and 2. Pardon me? Half of the 9? Half of 9 is 4.5, though. Any relationship between 3, 9, and an exponent of 1 or an exponent of 2. I'll try and tighten it up for you because it's Friday. Any relationship between 3, 9, and an exponent of 2. What? Excellent. 3 squared equals 9. Yes? What is then the reverse of this? The square root of 9 equals 3. Right? But what did you just find out right here? That 3 also equals 9 to the 1/2. Yes? Do you anywhere in here see a spot where we could write those exponents? The index would be 2, and 9 would have what power? 1. Does everybody see that? Everybody sees that? Great. Now look at 27. Is there a relationship between 3, and 27? What is it? 3 cubed equals 27, which means, how do I reverse that? Cube root of 27 equals 3, right? But 3 also equals 27 to the 1/3. So what does that tell us about this and this? They're the same. Do I need the middle 3? No. So, look at this. Any base to any exponent must be the same as the denominator to the index, the base to the radicand, and the numerator to the power. Does everybody see it? That's the only thing we are talking about today. If you have a rational exponent, the denominator becomes the index, the base becomes the radicand, the numerator becomes the power. And we proved it right here. Because if it happens once in math, how often does it happen? All the time. And we just saw it happen thrice in math, didn't we? All right. Now, my book is printed badly, as is yours. So, we are going to take this A here, and I'm going to rewrite it. I'm going to white out over this, and I'm going to move that B down here. And it was 27 to the 4/3, wasn't it? All right. Now, This one's really hard. And I like to start with a really hard one because it shows you that even though it looks really weird, you already know how to do it. Right? What's the base in A? 0.04. 0.04, yes? Which would be, because I'm not letting you use your calculators, that equals 4 over 100, doesn't it? To what power? To the 3 over 2. What do you know about any base to any rational exponent? Where does the denominator go? To the index. Where does the base go? To the radicand. And that is all to what power? 3. What is the square root of 4 over 100? 2 over 10. And all of that is to what power now? 3. What is 2 cubed? 8. What is 10 cubed? 1,000. So the answer is 0.008. Is everybody good? Even though that looks frightening, it isn't, is it? Because it's exactly the same thing as this. Is everyone okay? Now, based on what I said to you earlier, can I forget any of my other math rules from kindergarten all the way up? No. So have we seen something like this before, where I have an exponent outside the bracket and an exponent inside the bracket? What did I do? Multiply them. What is 1/3 times 2? 2/3. Yes! That question is almost never answered correctly. I know it's... People say 2/6. I know. And then I have to be happy that I usually wear glasses so I can't stab into my eye. But today I'm not. So please make sure, ladies and gentlemen, you think about your answers today, because you don't want me to lose an eye. So that is 8 to the 2/3. Does that look like that? So does that rule apply here? Of course it does. Where does the denominator go? Index. Where does the base go? Radicand. Where does the numerator go? It's the power. What's the cube root of 8? 2. What is 2 squared? 4. Done. Does everybody get it? Now, right now, our answers are working out perfectly, aren't they? 8 has a cubed root. 4 100ths had a square root. What if it didn't? What would you do? You'd simplify, right? And then you'd leave it as simple as you can get it. And I'll show you what I mean in a minute, because everything on this page works out for now while you're learning how to do it. What do I do here?
Okay, so the 3 is the index.
3 is the index. 27 is the radicand. 4 is the power. What is the cube root of 27? 3 to the 4th power, which is what? What's 3 times 3? 9. Then what's 3 times 3? 9. What's 9 times 9? 81. See, you didn't even need your calculator. D, E, and F are weird. What's weird about D? It's a decimal. So what should I do if I'm not letting you use your calculator? You could do 49 over 100, right? 49 over 100 to the 1/2 is the square root of 49 over 100. To what power? 1. So I don't need to worry about it, do I? What is the square root of 49 over 100?
7
Or 0.7. Please notice that relationship. 2 decimal square root goes to 1 decimal.
Oh, because 7 times 7 is 49. So.
Right? 7 times 7 is 49, but I need 2 decimal places. So all of you remember from grade 5 how to multiply decimals. 0.7 times 0.7, you forget about the decimals, it's 49. And then at the end, you needed one decimal place and a second decimal place. 1, 2, 0.49. Okay? What's different about E?
It's a decimal.
It's a decimal exponent. But isn't every decimal just a fraction? Yes. What is 1.5 as a fraction? 15 over 10, which you would then do what to? You would simplify it to 3 over 2. So this is 16 to the 3 halves. Where's the 2 go? Index. Where's the 16 go? Radicand. Where's the 3 go? Power. What is the square root of 16? 4 cubed. What's 4 times 4? Times 4? 64. So now you should be able to do F by yourself, right? What is 0.75? 75 over 100, which is, of course, the same as 75 cents, which is 3 quarters. Where does the 4 go? Index. Where's the 81 go? Radicand. Where's the 3 go? Power. We already know from this page what the fourth root of 81 is. What is it? 3 cubed is 27. Is there anybody that is going to look me in the eye and say that they cannot do this? It's just, yeah, right? Why can we not? Why have I all of a sudden said use a calculator here? Because what does that mean? That means it's the fifth root of 8 squared, yes? What's the biggest root 8 has? It's got a cube root, doesn't it? It doesn't have a fifth root. There is no number times itself 5 times that equals 8. So this is automatically irrational. So I cannot make it any simpler mathematically. I can only make it simpler using my calculator. Does everybody understand? So what would I do here? This is what is really happening, but this is a pain to put in my calculator. This isn't. What do I do to not simplify? What do I do to give me a better number there? Zach. Yeah.
So you shift and you get x, the power, empty power, so you shift that.
Okay.
And then you go right click and click x, and then you use the power.
Yeah. Or you could do what we did at the top, right? 9 x to the y, 1 divided by 2. So in this one, I could do 8 x to the y, bracket, 2 divided by 5.
And that's 2
Equals. And it's whatever it is. It's not important to me. What's important to me is you recognize when you can do it properly and when you have to use a calculator. Okay? What about this one? There is no 7th root of 0.6 to the 15th power. I can't do that. So it's a calculator issue. 0.6 x to the y, bracket, 15 divided by 7, close brackets. And it's a minuscule number. I don't care what it is. What's the point? If you have to use your calculator, you use it. If you don't, you don't. Okay? This is like 0.1013 or some crap. I don't care. 0.33. Great. Everybody good? All right. Now turn the page over, and we're going to do this. One of these is doable. 2 of them need your calculator. Which one is doable? A, B, or C? Just look. Don't do it. Just look and tell me which one is doable. It is A. Why, Joseph? Because 27, this is my M. And the equation is 0.01 times M to the 2/3. If M is 27, Is there a cubed root? So this one we can do, right? That would be 0.01 times m, not m, you idiot, 27 to the 2/3, which would be 0.01 times the cube root of 27 squared, yes? What is the cube root of 27 squared? 3 squared. 9. 0.01 times 9. 2 decimal places. How far do we move this decimal? 2 places. So my answer would be 0.09. Right? I can do it in my head because, or on paper, because this works. What about 200? Doesn't work, right? So it's going to be 0.01 times 200 to the 2/3. Now, since 200 doesn't have a cube root, this is a calculator question, yes? But what would you do? 0.01 cube root 200 squared. What if I said you don't get your calculator? I want it as simple as possible. What would you do with that? You do what we just did 2 worksheets on, yeah? 200 breaks down into what? Pardon me? 2 times 100. No cubes there, right?
No. 100 breaks down into
Isn't it? I'm just going to help you out here. 8 times 25.
sure.
What's the cube root of 8?
2.
2. So what comes out?
2.
2. So this is really 0.01 times 2 cube root 25 squared. Yes? Everybody still with me? What would this be? 0.01. What happens to the 2 when I square it? 4. What happens to the root 25 when I square it? 25 times 25. Because it's a cube root, which is 625, right? Now that is this, right? Now what would I do with that? If I was wanting it simplified without a calculator, what would I do there? What do I do every time I see one of these, if I can? I break it down, right? Isn't that 25 times 25? And isn't that 5 times 5 times 5 times 5? Is there a group of 3 there? What is it? So what comes out? 5. So now I've got 0.01 times 5 cube root what?
5.
What did I leave under there?
5.
A 5. 0.01 times 5 is 0.05 cube root 5. Does everybody see how I got to there? In the real world, would you tell your science professor that the brain mass of a polar bear is 0.05 times the cube root of 5, sir? No. What would you tell him? The estimated answer that you got with what? Your calculator right back here, right? Back here, you would have gone 0.01 times 200 x to the y bracket 2 divided by 3. In the real world, in math class, you would have done this. Does everybody understand? Okay? If you're not going to go on into future with more math, you need to be able to know how to do this type of thing because that's like a regular question in the real world. We use exponents all the time, especially in finance. Right? And all of you are going to have money at some point in your lives. Right? You're going to need to know how to do exponents like this. All of you. Whether you think you are or not. Or you're going to pay somebody to do that for you, and you're going to hope that they're not cheating you. Because if you don't understand it at all, they're going to take your money. This is what you need to be able to do if you're planning on going any further with math. Meaning, you are planning to go to university and do anything with science, anything with psychology, anything with geography, anything with kinesiology, anything with architecture. Okay? And that's just what I can think of right now in this 5 seconds. Everybody cool? All right. So this last one I'm not even going to get you to do because you can do it. Right? I'm comfortable. It is 8:39. Class is over in 10 minutes. I don't really think we're going to get to our quiz. So you guys should practice this on page 106. Okay, and I guess we'll quiz Monday because, today's an important day. Yeah, actually, that's what I was about to do, Toby. I was going to say, I got 10 more minutes. Maybe, shut up. I can look at if there's anything you guys are unsure about from this page. I'll actually put the whole key up right now, Toby, sorry. I'll put the whole key up right now, okay? Okay. It'll take me a second, so either work on page 106 or, just work on page 106. That's 144 times 2, so that's negative 72 root 2. That is not changing at all. That is 49 times 10, so that is 14 root 10. That is 147 is 3 times something.
Why is it helpful?
Just because it is. That's 3 times. 3 goes into that twice. 4, no, it goes into that 4. 12, 27. That's 3 times 49. So that is 70 root 3. That is... That is... 1... That is... 11. That's it. 104? 103? There's 103. As you can see, it was done in literally 30 seconds. So don't be all if I've made an error. I didn't really take time to think about it so you could see as many right answers as possible. Is there anything up there you want to see again, and I will go slower and make sure I did it right? Going once. It's being recorded right now anyway, so you have it. 16? That's not even on there. We're talking about something else. Everybody good?
Do you want us to just do up to 19 then?
You do as much as you see fit. I recommend always doing a little bit from every question. If it goes A to H, I always like to do A, B, and GH, just to make sure. Yo.
You're going to say, this is like, say number 10. You would actually subtract it. I would multiply all of these and all of these.
But no, because it says plus and minus.
And then you'd always do the ones that have the same number?
Yes, just like you would do it if it was X's and Y's.
Wait, I feel like I have another.
Okay. I feel like I'll have another answer. Okay.
There's no such thing as a fifth root. I can't do that, right?
There is a fifth root. 32 has a fifth root.
Break it down.
Oh, yeah.
Break it down. Observe. 32 is 16 times 2, right? Which is 8 times 2 times 2, which is 4 times 2 times 2, which is 2 times 2 times 1, 2, 3, 4, 5. The fifth root of 32 is 2.
Whoa. Oh, we can break it down.
Now, ladies and gentlemen, as Ariana said when she came up, the last time we saw fifth root, we were like, there's no fifth root, because that's the fifth root of 8. There is no fifth root of 8, but let's think about this for a second. 2 isn't a very big number, is it? Right? I can do 2 to the power of 10, which is what? It's 1,024, right? Which means that 1,024 has a 10th root. Because it's 2 times 2 times 2. There's a group of 10 there. Right? So, ladies and gentlemen, might I offer you a piece of advice? Remember how I said your life is made a lot easier if you know all the perfect squares? And all the perfect cubes? And all of your times tables? Knowing a few powers of 2 is very helpful as well. Because power 2 is a very powerful number in this unit, isn't it? Because it's the only even prime number. Toby. Number 7. This one right here. Root 15 times root 3 is root 45, right? Plus 5 root 15, right? Because there's no root there. So it's 5 times 1 is 5, right? Now that simplifies. 9 times 5. What's the square root of 9? 3, so out comes a 3, and I left a 5 under there. 3 root 5 plus 5 root 15. Can't add them together because that is x and that's y.
Right. So the answer is what then?
The answer is 3 root 5 plus 5 root 15. Brother.
Just this question. Hear me out. How did you get 21?
Ugh. That's 9 times 6, right?
Yeah.
What's the square root of 9? So what comes out? What's there?
I see. Just
Which one?
9.
It's the same thing. Simplify that. That's 4 times 2. So out comes a 2. 2 times 2 is 4, and I left a 2 under there. So that's 4 root 2. That, bring out a 3. 12 root 7. Got it right there. 9 root 2, but that is not 8. That is 4 root 2.
Thank you.
Hello, Selena. Have a good weekend. What?
do you need math for being a firefighter?
You know the only reason why Gio tried in his game yesterday was so he could get free donuts.
If we got 3 rushing touchdowns, we win.
I just gotta be coding the class.
Okay.